Alright, we're looking at solving rational equations today. We've got solving rational equations, we've got solving polynomial inequalities left in this chapter. If I remember correctly. So, solving rational equations. I think it should take about 4 examples to get this knocked out. First one, 4 over 3z plus 2 over z equals 5 over 6. Why is this called a rational equation? I got some fractions in there. Remember, what makes up a rational function? Alright, so if I've got a polynomial on top of a polynomial, that's what makes up a rational function. So I've got several different rational functions here in an equation, so that's why it's called a rational equation. Alright, so 4 over 3z plus 2 over z equals 5 over 6. Any thoughts on what I need to do to get started? Guys? Nick? Multiply. Say it. Multiply 2 over z by 3?
Yeah.
Okay. Cross multiply. Get a common denominator is what we want to do. We want to figure out what the common denominator is and then multiply everything by it. Which is kind of what you were saying. But we want a common denominator all the way across, not just on one side. That's what you want to do. So get a common denominator between all 3 items. So what would my common denominator be? 6z is my common denominator. And I want to multiply the whole thing by 6z. Okay. So I'm going to take 6z times all 3 of these. So what happens when I multiply those two? I could go ahead and multiply it out, but there's some stuff that cancels that makes it easier. What cancels? The z's cancel. And then the 3 and the 6 reduce to 2, so I end up with just 8. Z's canceled, the 3 and the 6 reduced, that gave me 2 times 4 on the top, that ends up with being 8. On the next one, I've got 2 over z times 6z. What cancels on that? The z's do, that leaves me with 2 times 6. So that means I get 12 there. Now on the other one, I have 5 over 6 times 6z. What cancels there? The 6, and it leaves me with 5z. So we're getting common denominator, and we're multiplying by it. And if you do it correctly, there should not be any more denominators. Okay? There should be no denominators if you do that correctly. Now I've got something that should be pretty easy to solve. We put the 8 and the 12 together. We get 20. And we divide. I get z equals 4. Now, whenever you're dealing with rational equations, you have to check your answers and make sure that something does not happen. What do we not want to happen when we check our answer? We do not want a 0 in the denominator. So we want to check and make sure this doesn't give me 0 in the denominator. What's the only thing that can give me 0 in the denominator in this problem? 0 is. So that means our answer is good, we like it, we're ready to move on. Questions on the first one? Correct. Which part? That's the same thing as that over there. So if I've got something on top and something on the bottom, they can cancel out. So the z and the z can cancel out. The 6 and the 3. 3 goes into 6 2 times, so that leaves me with the 2. 2 times 4 gives me the 8. Over here, the z and the z cancels, leaves me with 6 times 2, which is 12. Over here, the 6 and the 6 cancel, leaves me with z and 5, which gives me 5z. All right, next problem. I have 6p over 2p minus 1 minus 3 equals 3 over p. So what do I want to do? Common denominator. Let's see if anybody can come up with a common denominator on this one. Scott?
6p minus 1.
Nope. Nope. Nope.
Just p.
Nope.
2p minus 1.
Nope.
6.
Now, what we just talked about in that last problem, what has to happen once we find our common denominator and we multiply? Everything, all my denominators have to cancel. Okay, so think about that.
2p squared minus 1.
What'd you say?
2p squared minus 1.
Nope, you're getting closer though.
3p minus
Nope.
1.
What's going to cancel out the 2p minus 1?
2p plus 1.
Wouldn't it just be 2p minus 1 is going to cancel out 2p minus 1? What's going to cancel out the p? P is.
Is that the answer?
So, my common denominator is 2p minus 1 and p. No, just leave it. You leave it alone. Okay, here's the rule of thumb. What is 2p minus 1? What can I describe 2p minus 1 as? A binomial. If you've got a binomial, the binomial must always be in your common denominator. So since this is 2p minus 1, I knew that part of my common denominator had to be 2p minus 1. Okay? Then I had p, and this I could think of this as 3 over 1. If you're dealing with monomials, which is what p is, then you get a common denominator between the monomials like we did on the first problem. Okay? But the binomials always have to be in your common denominator, and then get your common denominator between your monomials. Okay? But again, you need to be thinking that whatever my common denominator is, what has to happen when I multiply? It has to cancel the denominators. Okay? So keep that in mind. So when I take this times my first fraction, what cancels? 2p minus 1, so that leaves me with 6p times p, which is 6p squared. On the next one, I have no denominator, so that means it's not going to cancel. So that means both of those things remain. On the other side, what cancels? The p does, and that means I've got 3 times 2p minus 1. You've got to make sure your denominator cancels. If your denominator doesn't cancel, you did something wrong when you found your common denominator. Alright, so now we multiply this out. Now this 3 and the p, I'm going to think of that as 3p whenever I distribute it here. So 6p squared plus 3p, and on the right, 6p minus 3. Okay, if you guys mess up on this problem, it's going to be right here when you distribute, and more specifically, it'll be right there, because what are most of them going to give you right there? A minus 3p, instead of making sure that's a positive 3p. So if you screw up on these types of problems, it's usually because you did not distribute correctly. So make sure you pay attention to when you're distributing. So now, these two cancel out. I have 3p equals 6p minus 3. What's that? So let's move the 6p over, which gives me negative 3p equals negative 3, which means p equals 1. What do I need to make sure of though? And it doesn't give me 0. Okay, I plug in here, I'm good, because that's 2 minus 1. I plug in there, I'm good, because it's just 1. So that means we do like the answers. Question on that one? Back into the original, just the denominators. You want to make sure you don't get a 0 in one of your denominators. I don't care about the numerator. Okay, 4 over x squared minus 6x plus 8 equals 3x over x minus 2 plus 2 over x minus 4. This one's slightly different than the first two. What's different about this one? I've got a trinomial. What do we need to do to trinomial? Factor. First thing you want to do whenever you're doing these types of problems is make sure your denominators are factored. Okay, what does that tell me? How does that tell me I need to factor it? Factors of 8, what? Adding to get 6, so what would that be? 4 and 2, this tells me the signs are the same, this tells me they're both negative. Once I'm factored, now I'm ready for my common denominator. Hunter says x minus 4 and x minus 2. Okay, and how can I tell whether or not that is the correct denominator? They're binomials, so I know I needed the binomials, but how do I tell that's correct? And I don't need anything else. Right, I need to make sure my denominators will cancel out. So if I take that times the first one, both of them cancel and I just get 4. When I take that times the second one, what cancels? X minus 2. And when I take it times the last one, the x minus 4s cancel. And I'm left with that. So you can always tell if you got a correct common denominator because you need everything to cancel. So now we distribute. So 3x squared minus 12x plus 2x minus 4. Now what? Solve? How do you want to solve? Put my like terms together? Move the 4 over from the left to the right or the right to the left? Left to the right. So if I move that over, I end up with that. What told you to do that, Natasha? What tells you you're going to have to factor? Right. So we should have noticed that I had a square on this one, which tells me I've got to factor. And if you have to factor, you got to get everything on the same side. Okay, what am I going to do to factor this?
Slide and divide.
Slide and divide. So x squared minus 10x minus 24. So factors of 24 subtracted to give me 10. 12 and 2. Different signs, biggest one's negative. And when you slide and divide, don't forget to do what? Divide. So I need to divide by 3. So that gives me x minus 4 and gives me 3x plus 2. So what x values did we get? 4 and negative 2 over 3. Do we like both of them?
No.
No. Which one do we not like? We do not like 4. Kendrick, why do we not like 4?
Because when you plug it in, it'll become 0.
We plug it in, it makes my denominator 0, so that's why we don't like it. So my only solution on this one is negative 2/3. What happens if both solutions don't work? What's my answer? Yeah, no solution is my answer if they both don't work. All right, one more. X over x plus 1 minus x minus 1 over x equals 1 over 20.
x and x plus 1.
X and x plus 1?
Yeah.
You guys like that? And 20. Because what has to happen with my common denominator? It has to cancel my denominator. So x plus 1 cancels this, x cancels this one, and 20 cancels that. So I need all three of them. So always keep that in mind when you're getting your common denominator. It has to be able to cancel all your denominators. Alright, so when I multiply times the first one, the x plus 1's cancel, so that leaves me with x times 20x. Okay, when I multiply times the middle one, the x's cancel, so that leaves me with 20 and x plus 1. And when I multiply times the last one, the 20 cancels, and that leaves me with x and x plus 1. Make sure you understand what we did there. Alright, so I'm going to get 20x squared. Okay, if you have multiple binomials, you always want to multiply the binomials together first. And what do we notice about x minus 1 and x plus 1? Conjugates is what I'm looking for. You're thinking of factors. If those are conjugates, what do we do with conjugates? Front times front, back times back. So x squared minus 1. Over here I have x squared plus x. So now distribute the 20. So Reagan, what should I do next?
20x squared cancels out. And then subtract the 20.
Very good. Excellent. What told you to move the 20 over?
Subtract the. You have to have it equals 0.
Because what are you getting ready to do? You're getting ready to factor. What told you were going to factor?
X squared.
Very good. That's what I wanted to hear. Excellent. So we had to move the 20 over because we had an x squared, which told me I had to factor. If I'm going to factor, everything has to be on the same side. All right, Lauren, how do we read that?
Factor the 20, then subtract the
And those are excellent. All right, this negative tells me different. This one tells me excellent. So that gives me x equals -5 and 4. In Kurt, we always need to do what?
Check if it equals 0.
Check and make sure they don't cause my denominator to be 0. In this case, they don't. So we like the answer. That is solving rational equations. So when we're solving rational equations, what's the first thing we need to look for? Before that. Before we get a common denominator, what do we need to make sure of? What do we do on our third example? Right, we need to make sure everything is factored first. Make sure everything's factored. Get a common denominator. Make sure your common denominator does what? Cancels out all the denominators. Good, Christian. Okay? Then you are multiplying and solving. And Bobby, what do we always do with our answers? Alright, make sure my answers don't get to 0. If they do, 0's in the denominator. If they do, then we don't like them. We cross them out. Good.